All right, this is from section 3.7a on optimization. This is the example number 1D, okay? It's talking about two numbers. It asks us to find two positive numbers that satisfy the situation. It says the sum of the first number squared and the second number is 27, and the product is a maximum. So the first thing we have to do is come up with our two different equations, okay? Let's start by the first little piece of the sentence that says the sum of the first number squared. So let's call the first number x. And the second number, let's call the second number y. It says the sum of the first number squared and the second number, so sum means plus, is, so equals 27. So I came up with that equation from the first little piece of the sentence. Again, it says the sum of the first number squared and the second number is 27. Okay, let's come up with a second equation. It says the product of the two is a maximum. So product means multiply. If I multiply the two numbers together, that gives me a product. I don't know what the product is, but I want this product to be a maximum. So this is the equation that I want to differentiate so that I can find its maximum or minimum value. Okay? There's too many variables obviously in this equation. There's an x, there's a y, and there's a p. So let's go ahead and use my other equation and solve for y. I have y equals 27 minus x squared. So that means in this equation, can I plug in my y equals? So I have x times, and instead of y, I can plug in a 27 minus x squared equal to p. So now I have one equation with a variable x. I can differentiate it, and I can find my values. So I'm going to go ahead and find the derivative here of the product. I have my second times my derivative of my first, plus my first times the derivative of my second. 27 minus x squared minus 2x squared. So my derivative function is negative 3x squared plus 27. Right? And so if I want to figure out where my critical numbers are, my relative max, relative min, so I can find a maximum product, I'm going to go ahead and take this derivative and set it equal to 0. I'm going to move the let's move the 3x squared over, make it positive. Let's divide both sides by 3. Let's square root, and I get x equals plus or minus 3, right? Plus or minus 3. So that means our first number is either a positive 3 or a negative 3. Now it says in the directions I want two positive numbers. So I'm going to actually only take the positive 3 here as my x value. So I know that my first number is 3. If I know my first number is 3, how am I going to find my second number? Well, can I take that first number and plug it into this equation that we made in the beginning, where my first number squared plus my second number is equal to 27, and I can solve it from there? And I get y equals 18. So I have two positive numbers, x equals 3 and y equals 18, where the product is a maximum, and the first number squared plus the second number equals 27. It satisfies all our conditions. Hope that helps.